Hey guys, so we are going into rule number 3, angle side angles. Let me flip my computer around here. Okay, so angle side angle. Similar to one of the rules that we've already used, this method is used when the side between our two angles are marked. So here's two examples. I have this triangle that's connected to another triangle, but right here, this side that they share, due to the reflexive property, is exactly the same. It's congruent to the other side of the triangle. So we're going to put a little tally there. So I have this angle, which has 2 tallies, is congruent to this angle, which has 2 tallies, a side that's congruent to the other side, and an angle that has 1 marking congruent to the other marking. So if you separated these, try my best here. This is what the two triangles look if you just separated them. So these two sides we're saying are congruent, and it's like the triangle was rotated a little bit because this angle is congruent to the opposite angle of that other triangle. So we have angle side angle, spells ASA. If you started at one of the angle points and continued to another angle, you would hit all these markings. That's how you would know if it's an ASA. Now over here, this triangle, it makes an X right in the middle, so that means these two angles are congruent because they are vertical. So I have one tally mark congruent to that tally mark, a side which they marked congruent to that side, this angle congruent to that angle. ASA. And again, since the rule begins with an angle, you start at an angle and draw to another angle, and you should have 3 markings. One in the angle, one on the side, and then another one at the angle. The fourth rule is called angle side. Now, we do not ever spell the word ass, ASS, for angle side. We do not spell that, or we don't spell it backwards. So no curse words in geometry. For angle side, however, this is when we have 2 angles marked and then the side that's excluded from those 2 angles, meaning the 2 angles are marked and in between it, we don't have a tally in between it on that side. So in number 9, again, we have vertical angles being shown. So these 2 are congruent. And notice how I go from an A to a marked S. So if I start at an angle, there should be no marking along that side. I should hit another marked angle. And as I keep going, I hit a marked side. And I should see that same pattern on another triangle. And then in number 10, again, we have this reflexive property happening. So those 2 sides are congruent. And if I start at an angle, I should be skipping a side. So that means I'm skipping, there's no marking on that side. That's what I mean by skip. I reach another angle and it is marked. And when I reach my second side, that side has tally marks. Same thing over here. Angle is marked, side is marked. So this is an AAS. And the last one, if you ever do come across that you're spelling an angle side, it's actually not called angle side. It's actually called an H, put an L because that's the next letter, an HL, called for hypotenuse leg. So this only works with a right triangle. So if you have a little right triangle, because of that little box that's inside the triangle, then try to gravitate your mind or your options for it being HL. So over here, I see that I have 2 triangles that are sharing this one wall. So that is using the reflexive property. Now, if I started at an angle that's marked, This is the same on that side because they're a linear pair. If I started at this box and I traced the triangle, I would hit an angle, a side that's tallied, and another side that's tallied. It spells the word S, A-S-S. Well, we know we can't use that word in geometry. So then I look again, I go, okay, well, this is a right leg, a right angle. This is called a side, but for a right triangle, the two sides coming off of this little box are actually called legs, like I have up here in this picture. Diagonal of that right angle box is called the hypotenuse. So I have a leg marked in this triangle, and across from the box is called the hypotenuse, and that is also marked. And I have the same exact thing in the other triangle. A leg marked, hypotenuse marked. So this is congruent by HL. Number 2, again, we have vertical angles, so this one is also 90 degrees. The two sides coming off of the right angle, I notice one of them is marked, so that's a leg so far. Across from the box is my hypotenuse, and that is also marked. So this is considered an HL. All right, so let's practice some of these. For number 1, if I start at an angle, or I start at any marking, I'm hitting an angle, a side, and an angle. I look to my other triangle that they're showing me. I have an angle, a side, and an angle. Those are all marked. So this would be an ASA. For number 2, what could I add tally marks to? I'm adding my tally mark to this line right here because both triangles share it and they are congruent to each other because of the reflexive property. All right, now I'm going to begin at the farthest angle, and I have an angle, nothing, an angle, and a side. Same thing over here, angle, nothing, angle, side. So which rule would this be? It is an angle, angle, side. How about number 3? Two triangles, they're not touching in any way, so no vertical or reflexive angles or reflexive property. How would I prove these two to be congruent? Am I using angle, 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 side, or neither? We can't prove them congruent because the tallies don't make any sense. The markings make no sense. All right, hopefully you noticed I have an angle, nothing, an angle, and a side marked. And on this guy, I have an angle, nothing, an angle, and then a side mark. So this is AAS. Let's take a look at number 4. So number 4, I have an angle, nothing, an angle, side. So far I'm veering towards AAS. But now when I go to this triangle, I have an angle, a side, and an angle, all cohesive like that. These two triangles do not match up. Their tally marks don't make any sense. So they can't be congruent because they're using two different rules. The first one's using AAS. The second one is using ASA. So this would be an example of a neither. All right, what do you think for number 5? All right, maybe some of you immediately thought hypotenuse leg because you have a right angle. Yes, but remember, your legs are the sides coming off of that right angle, and they are not tallied in this example, and they are not tallied for the other triangle either. So it can't be hypotenuse leg. Instead, I have an angle, nothing, an angle, a side. Angle, nothing, angle, a side. So this is angle, angle, side. How about number 6? All right, reflexive property, I can add a tally mark. So I have A, a side, another angle, and I see the exact same thing in the other triangle, so this is ASA. What do you think for number 7? I have an angle, a side, or even if you did it the other way, side, angle, angle. Both of those mean the exact same thing. We're just writing it backwards. So this one is true by angle, angle, side, or if you want to do backwards, side, angle, angle. Number 8 is going to be the same thing. We have an angle, a side. And what about number 9? We have an ASA because it's all cohesive. They're right in a line, an angle, and on the way to the next marked angle, the side in between is tallied. And I have the same thing on the other triangle. All right, that's just being able to identify when looking at a triangle what markings are there or what markings have to be added in order to prove those two rules. Now, we are going to look at some problems where they're giving us how the two triangles are congruent, and we have to give extra information in order to make that rule true. So let's switch my color here. All right, in the first example, it says that these two triangles are congruent by HL, hypotenuse, leg. So I look at where my right angle is, so I can identify that the two sides coming off of it are my legs. I see that this one is tallied. I look at my other triangle. These are the two sides that come off of it, so these are my legs. I see this one is tallied. So they gave me the information that this leg, PQ, is congruent to this leg, KL. So I don't need to find a leg. I notice that my hypotenuse is not marked. The hypotenuse is across from that right angle box. So I need to add a tally there, and this one as well. Now I actually have to physically write out what that side is. So this side, RQ, needs to be congruent to this side, ML, in order to make this congruency statement of HL true. All right, now you guys are going to try number 2. What information is needed in order to prove these two triangles congruent by hypotenuse, leg? Well, across from the box is my hypotenuse. So my hypotenuse is already mentioned in the picture that they gave me. I need to now pick a leg. It's important to make sure that you're stating the correct leg or matching it up. So I'm going from the right angle box up, from the right angle up. So I'm saying that VX, I'm going to write it on the side, VX has to be congruent to AC in order to make this true. Now, I'm saying that. You could have said the other leg, VW and BA. As long as you're picking one of these and saying that they're congruent to each other, you even could have mixed and matched. All right, number 3. I want to prove angle, angle, side. So let's see what they gave me. They gave me one angle congruent to this angle. I know that this side is congruent to the other triangle side because of the reflexive property. So they gave me an angle. I can cross it off. I just gave them a side, and I'm going to write that side. So starting from my marked angle, E, going to D, has to be congruent to the other triangle side. Well, I'm starting at this angle that's already marked. So I'm starting at this angle that's already marked, D. It's important of how you label these. If you do ED is congruent to ED, you're saying that this angle and that angle are congruent, which is incorrect. All right, now since I found an angle that they gave me, a side which I gave them, I still need another angle. But this is important because it cannot be the angle that's on the opposite side, because then it would be true with ASA. So I have to mark angle I and angle C, because now if I label this, I have angle, angle, side. If I marked this one, I would have had ASA. And then I write angle I is congruent to angle C. All right, take a look at number 6 because it's another AAS. In number 6, what do I need in order to prove these two triangles congruent? Well, they already gave me an angle and an angle. They already marked those. The side is not in between those two angles. So if you said QP is congruent to DE, you would be incorrect, because that would prove ASA. You either have to say that QR is congruent to FE. Again, Q and F are the same angle. That's why I'm beginning with them. Or you could have said DF is congruent to PR. Either one of those answers is acceptable, and if you switch these, that's acceptable along with the first one. All right, the last rule that we're going to prove is angle, side, angle. So in number 4, I have an angle that's already marked, congruent to this angle over here, so I can cross out an A. I know this side is going to be congruent because of the reflexive property, so I can add those tallies, and I'm going to write it. E to D for my triangle on the left is congruent to DE, my triangle on the right. Notice how I'm starting with the angles that are marked for both of these statements. My last angle is on the other side of this side, DE. So both angles that make up that side are marked. So angle D has to be congruent to angle E. All right, you guys are doing the last one, number 5. What 2 items, because we already have an angle that's marked, what 2 items do we need for angle, side, angle? All right, we know S over here is congruent to the other S in the other triangle, and you probably wrote that, but remember when you have, if I'm writing an angle that's mentioned twice, I can't do angle S is congruent to angle S. That makes no sense because it's like, hey, which one are we talking about? Instead, you have to use 3 letters. So I'm starting at the one angle that has the tally mark. LSN is congruent, starting at the one tally mark, RST. The angle you're talking about is always in the middle. Always, always. So that would be the angle that's congruent. And now the side that you should have said, there's only one option. It's the side between the 2 marked angles. So I would have to say from angle L to S, or the other way around, SL, is congruent to RS, or the other way, SR.